Yeah, everybody, thank you so much for coming. We have a fantastic guest on with us this evening. Dave, I want to sing a whole bunch of your praises, but maybe first let's start. Well, as everybody knows, Kyle Forster, founder of RunWhen. Dave, why don't you introduce yourself quickly, and then we can get into it. This is one that I've been really excited about. Really, really excited.
Likewise. It's always fun talking with you. Yeah, hi, I'm David, search engineer at GitHub currently. I have a very short history in search engineering and a very long history in like data pipeline engineering, etc. But super happy to be here and talk about search, because it's so important.
Yeah, I feel like obviously there's a personal interest and passion of mine. I wrote 2 different versions of our own kind of internal search engine that sits underneath our assistant algorithm. I've been looking forward to this, frankly, because I have a whole bunch of questions that I wanted to ask about the right way to do search. But I did want to open it. You said something right before we turned on the cameras, and you said, I see all kinds of people. I'm just going to read off my note. They think that AI is the answer to their search problems rather than fixing search as the answer to search problems. And that to me resonated so deeply. Just as an opener, I was hoping that you would just unpack that for everybody who's listening in for that.
Yeah, I think there's this like inherent belief that oh, we get AI search, we plug it in, and it becomes like instantly better. But I think one of the problems that you have when you do this is you end up running into like, okay, I've still got muddy search, and then I add AI on top of it, and then it's like muddy AI search. And that's where you start to see like all of these like weird things that we saw when people started using LLMs with like RAG, for those who don't know, is retrieval augmented generation, which is where you like search some results ahead of time, you feed it to an LLM in an attempt to make it better. But a lot of times it's like if your search wasn't good to start with, if you feed those results into an LLM, it's just going to confuse it, and it's going to make your search seem, or your results seem weirder, or like give like very strange responses. I saw one company that rolled this out, and they had like automatic responses to emails, and they were shocked when their AI responder rickrolled someone, which is they sent a video of Rick Astley as one of the like, hey, here's how to resolve this, and link to the rickroll video. I mean, so, and this is where I'm saying like, it's really important to think about your search as search problems. It's not just something any software engineer can step into. It's like, it's an area with a lot of specialization, a lot of tooling, and you almost need like kind of like a data science-y ML type person. Maybe not necessarily ML, but data science-y for sure, to like get in there and start like evaluating how can we make search better first.
And I don't want to steer the conversation too much towards the current day job. Right? That wasn't. But I'm really curious because I feel like for us, I've faced this problem a lot. When we say search, for us, our search engine doesn't return web pages. Our search engine returns automated tasks that like somebody should run in their environment to fix something.
Yeah.
When you think about, and the result like that is very different. When you think about code search in your day job, my guess is a lot of people immediately think like, well, web search and code search are kind of the same. I'm just guessing that they're very, very, very different. But
yeah, this is a really interesting place because GitHub has taken a hard branch, and we actually we have 2 internal search systems. This is all public information, so I'm happy to share it. But the first search system is code search, and it is like specifically tailored to and tuned to just returning code search results. Because text search, traditionally what you do is you will break apart words into tokens, and each token might gets put into a dictionary basically that links back to all the documents that reference that word. And when GitHub was kind of going through this transition and trying to make code search using a text search engine like Elasticsearch, they were just like, this is not working. And that's where our internal code search engine came around. So they're very different. And even further, like there are a lot of use cases for search that people wouldn't necessarily think of, So like, for example, you were just talking about finding and returning scripts that people should run. search can also be used as like a recommender system, which is where like, hey, maybe I'm going to, you previously looked up this, I'm going to recommend that you also look at this. Or even further, like there are some really cool things you can do, like deduplication. Like, hey, you are trying to create this issue. This issue that looks very similar to that one already exists. Like, do you still want to create this issue, or do you want to go like contribute to this other issue? It's an example of some places where you could use search, that aren't traditionally what you think of.
And do you think that I've always viewed search and recommendation engines as under the covers basically mathematically the same thing?
Yeah.
I think a lot of people think of them as so wildly different. I don't know, you're the expert. What do you think?
So I think they're different in the sense that a lot of the methodologies you might use are different with them. So like we'll say, for example, text search. This is like a really interesting one. A lot of people, when they like look in a search bar and results are returned, what they think has happened in the back end and what may be happening, depending on which search you're using, is, like, oh, it looked for the words in my queries, it found them in matching documents, and then it just returned those documents. So that's like a baseline search experience. That's what most people have. The like next tier of search experience is like building a tailored set of, search. And what I mean by that is like, all right, you are looking for an issue. You probably aren't looking for an issue in any repo. You might be looking for an issue in repos that you've contributed to. You might be looking for a recent issue. You're probably looking for an issue maybe that a lot of other people have encountered. So maybe an issue with a very high page count. So these are like, this is the difference between like, the baseline search experience, which is like what we described earlier, where I was like, you should just improve your search. These are the things I'm talking about. Is search is not just this like flat plane of I look up text, I find text. It's all these other facets like, hey, maybe a lot of people keep coming back to this issue. We're going to boost that one. Or, hey, maybe this issue is 6 years old. It's going to get decreased in the results. Chances are you're not looking for an issue 6 years ago. But so those are the types of things that you might look at. And recommender systems they can be viewed as different, but they're starting to become much more the same. So like we'll talk about vector search. Vector search is one of like key areas I feel like that recommender systems are used because it's like, okay, you have tags or attributes, this person is, has a salary of approximately this range, has interests that match this. So I'm going to recommend this item, because I think it fits in with them. And that's traditionally been done in vectors and it's computed with a bunch of math. And that's what we're starting to see in like traditional search as well. We're starting to see people using these vectors to represent text and then using it to say, hey, are these, documents semantically similar? Do they seem like they have similar content and composition?
The first one internally, we used to talk a lot about Google Map search because it was just so intuitive. If you're searching restaurants and you're zoomed pretty far in, it certainly means one thing. But if you search for restaurants and you're zoomed at like country level view, like you probably don't want all the restaurants in that country. Go figure. Like there's very dependent additions to the query.
Yeah, exactly. And I think actually like this is where it's become really hard as a search engineer because you called out the big G word, Google. They have done such a good job of narrowing down exactly what things people are looking for in search. It almost spoils your search experience everywhere else because you go to some little mom and pop site and you search and you're like, why can't I just find the tinsel shaped cookie cutter that I'm looking for? And it's because search it's serious engineering. It takes a lot of thought and a lot of tooling to make sure it's right.
And I'm curious for folks, at least I'm curious what you think. In my view, watching Glean now just beat Wiz's record of the fastest company to $100 million in ARR in history. Amazing thing. I feel like almost partly because of RAG, we're seeing this renaissance in enterprise search.
Yeah, I think,
What do you think?
I mean, I think it's exciting on one hand, because like the focus is turned to search, which a lot of times, search is put in the back burner. It's a feature, when for so many companies, and I'll say even GitHub included, like, this is the one thing I like to talk about a lot because it helps my job, is search is everywhere in GitHub. It is not just the search bar. So you click in the search bar, you search some things up, that is a very obvious use case of search, but it's starting to show up in other places that it's really interesting. So like our issues view right now. So like when you go to github.com/ org repo / issues, that view is powered by search actually. Instead of, just a MySQL view, we've said, hey, look, people come here enough and they're looking for tags, they're looking for words and issues, they're looking for these text terms, that has now backed by search instead of like a MySQL database. So with regards to like, RAG and how it's made search popular again, I think it's really great because I do think search is really important and I do hope that more people pay attention. But I think the one thing that's very problematic is they think, oh, RAG is a solution to my LLM accuracy problems, or RAG is a solution to my search problems, when really it's like you put bad in, you're going to get bad out.
Yeah. No, I mean that. Well, having watched my team and I prototype a small RAG pipeline, both for our own use and as a special for one of our customers. I mean, it was pretty stunning how quickly we could make a really bad RAG.
Yeah.
You
Yeah.
know, it was a weekend and it sucked. And
Well,
like after a week, it got a little bit better, but not that much.
yeah. Well, and I think that comes down to like tooling again. So like for those in the search space, we have, this idea of relevance. And the way that we basically measure relevance is we, have some query, we return some results, and then we have real people come and, say, hey, this result was a really good match for this query, or it was a poor match. And then based off of that, those results produce a number. And that number is actually a calculation of how good or bad the search was based off of how high up the best result was. So this tooling, this relevancy tooling, you start with, a handful of queries and a handful of results that have been judged, and then you move on to potentially hundreds of other queries. So once you have that in place, it becomes really quick to say, okay, I made a change, I tested it. Did the overall results get better or did they get worse? And it's just not something most people, most teams know about, just because it's a very search specific set of tooling.
I'm curious on relevancy because we've just started experimenting a little bit with, in order to augment our test cases of hand, by hand. Hey, given this
Yeah.
query, hey, here are the top 5 results, like we kind of
Yeah.
used to do manually. Trying to use LLMs to help us expand that, couple hundred cases out to a couple thousand. And
Yeah.
for us, for what it's worth, we saw, I mean, just this is very, very recent on our end, but a gigantic change by using DeepSeek, like a reasoning model. Even
Yeah.
O3 probably would have done it, or O1, but a reasoning model versus a traditional LM seemed to match our intuition for relevance ranking
Mm.
like insanely well to just basically help us produce unit tests. So we're just using it to produce
Yeah.
lots of test cases.
Yeah. Yeah.
But
No,
it's kind of a universal thing.
yeah, no, I think there aren't many companies that are doing tests like that. Like that is I would say you guys are the outliers if you're testing the relevancy. Now, uh getting down to like building a really robust metric around that is very helpful, because like you said, making sure a result is in the list, that's kind of like the first tier of relevancy. Then you want to see like, all right, now how high is that in the list as well, which is really important. But no, as far as like using LLMs, I'm seeing a lot more people nowadays, a lot more companies embracing LLMs for creating these what we call judgments in the industry, which is like, hey, given this query, given these results, like which is the best? And there's some like really interesting research happening right now as far as like people creating profiles for these people. So, say you are a product manager, and this is, these are the attributes of this person. then also rank these, so this is adding another layer of depth where you can start getting past the, this is the query, these are the results, and start even fine tuning on who your expected users are. And because it's challenging, it's very challenging to create these like data sets for testing. And that's where LLMs have come in and just like lowered the bar so much. I mean, it's just so much easier to create these data sets now.
I mean, yeah, I don't want to go too much into like our own personal experience, but I would, I would say, because we wrote the search engines V1, 2, and 3 on our side pre-LLMs. And yeah, the difference that suddenly we had in the ability to generate test data was just gigantic.
It's huge because it's time consuming, and it can also be hard to get buy-in from all the different people that you're like, hey, can you help me build this test data? It's like nobody wants to spend their time doing that,
Yeah, no, it was I would say that was kind of like the biggest bottleneck that we had in many cases. And I guess for us as an organization, as we were kind of going through, this was back 2 years ago, give or take, when we were doing Search V1, 2, 3. We were having all of these debates, very early on, of should we start from kind of a keyword BM25 basis, or should we start much more from a semantic search embeddings basis? I feel like while that was a little bit of an esoteric debate like 2.5 years ago, now with embeddings like one simple LLM call away to get extraordinary high quality embeddings, feels like embeddings have become more of the lingua franca of engineering in our industry. And like you can say embeddings without a lot of people going like, wait, you want to represent text as a which? As a what?
Yeah.
I'm curious, like, how would you revisit that debate now? And is that something you wind up seeing in your day-to-day conversation?
All the time. I mean, we're evaluating, vector search, of course, for GitHub, and we reevaluate it pretty frequently. I think the two things that are really challenging to adopt those embeddings is, number one, it's expensive. It is much more expensive compared to traditional text search. Traditional text search can work very well when it's written to disk. It can be retrieved efficiently. Versus embeddings where, vector search, more often than not, to get good results, needs to be all loaded in memory, which is okay, given its memory footprint is smaller than the original data, but it's still expensive. Then the other part of this, and this is the hardest part to get around, is your user base has to be in tune with the fact that the way that they should search is changing. So, for example, on GitHub, I would say our average query is probably anywhere between 2 and 6 tokens, we'll say, which is like 2 and 6 words. That doesn't work super well with a lot of semantic search models. People aren't asking questions and expecting responses in that way. So, like, I think there's like becoming this diversion where, like, for things like RAG, it makes a ton of sense because that is how people are doing things. But it even still has its shortcomings, and maybe we'll see some of that change with, there is, what is that called? Of just sparse embeddings. Sparse embeddings, I think, is going to assist a lot there. But when it comes to like precision of search results, especially if you're using super precise terms that are domain specific, that's where BM25, you almost just can't beat it, Yeah,
I just saw a question pop up from Abdel on the coming in. I think I just showed it up on the screen because it feels very relevant to the topic that we're talking about at the moment. And I had a question, but I want to let you to respond to this one first, and then I have a burning question for you right next.
Yeah, absolutely. So the question is, as I read it, would it be safe to assume that embedding modeling is more responsible for relevance rather than the vector DB itself? So I'm actually going to throw two things out there. The question is really asking, like, hey, is it more important to have good embeddings, or do you need also a good vector DB? Like, does the quality of the vector DB affect relevance? And I'd say there are two things there. At the core, the embedding is going to be what drives the most relevancy, with the caveat of you can host that embedding in a vector search engine in a way that it is never able to be retrieved well. And that's because there are like a couple different ways to like represent those embeddings. Everyone or most people are familiar with like HNSW, which is hierarchical navigable small world graphs, which has become like the default for vector search. But there are other ways. So there's IVF, which is I don't actually remember off the top of my head what that stands for, but it's a more bucketed way to do vector search. And the way that you host those embeddings could have a huge effect on relevancy. So like IVF, you could see like, I think, what was it? Like a 5x decrease in relevancy if your bucketing is wrong, which is huge, right? So, and again, like you'd have to know that your vector search engine either supports IVF or does not. You'd have to also consider other things. So like I mentioned different attributes of search. So let's say, for example, like page views. Maybe I want to boost documents that have really high page view counts. Well, in order to combine my boost for high page view counts with the vector score, so like vector search will retrieve a score, and then I want to boost or decrease that score, your search engine also has to be able to accommodate that. So I would say at the core, the embedding space is where I would spend the most work to get a good relevance, but also you do need to check on the features of your search engine to make sure it can support your embeddings. And even embedding lengths. Like I think Elasticsearch is now up to 4,000. We're going to say 4,000-ish for, how many tokens it can hold versus, something like FICE, which can hold, I think, like 15 to 20,000 tokens. So there's a lot to consider when it actually comes to the search engine space itself.
I mean, it's fascinating. I just want to loop back for a second because I'm still musing on this point that you brought up that, hey, when you have when your typical search query is 2 to 6 tokens, keyword search is fundamentally set up to succeed because I'm assuming implicit in that is like 2 to 6 like fairly long tail tokens is kind of the norm.
Yeah.
Whereas when your search is like a full English language question, it's phrased as a complete sentence. Oh, well, really, that's probably mostly very common tokens.
Yeah, it's
semantic versus BM, like versus keyword, like a totally different search technology depending on the query, not on the target.
Yeah, actually, so this was one of the like interesting things that I think the Open Search project did a fair bit of research on when it was first being investigated. This idea of like, which is better, air quotes, with all the sample data sets out there. And almost always they found that it was some combination of the two that produced the highest quality results. So for your like super long tail queries, semantic search is going to be like your bread and butter. But for short queries, there is much more there's much more value in using traditional BM25 and doing lots of boosts and tunes, etc. But combining the two, you can kind of almost always end up in some middle ground where you're like, all right, our results are really good and we're covered on both ends.
That's interesting.
Yeah. And actually that's like a whole branch on its own is like scoring for BM25 documents and vector search documents are on two completely different planes. Like, it's like 0 to 1 or it's, like an infinite range of numbers. So it gets challenging. How do you combine these documents well? Like how do you build a baseline? And for some people, it's actually using machine learning models to rescore after you've done the retrieval piece. But then it gets challenging because how do you paginate that? Like, okay, well, I have 5 pages of results. How do I combine these results stably for 5 pages?
I'm glad the pagination problem isn't just us.
Yeah, no, it's stable pagination. Well, and like I'll say at GitHub scale, it has just become such a incredible challenge because like I have people who genuinely have use cases to go past 500 pages in their issues. And I'm like, why do you have 500 pages in your issues? Can we like work this down? And they're like, no. And I'm like, great. So I have to support that. And now I'm going to work on it.
Fascinating.
Yeah.
That's it. Along these lines, do you think that because I've seen that too, it feels like there's a fair amount of literature, like in general, the combination of BM25 plus, or call it just general keyword plus, a semantic search, combining the two would generally lead to better results. Do you think that's as true for code and for other structured data as it is for English language search targets, or is that natural language search targets?
I don't know that I can really speak to that. Yeah, I have not personally tested it with code search, and because I think this is the other challenge is like, actually, this is something that I'm still kind of simmering on with regards to GitHub search page, because like in my like best case world, I want to turn GitHub search page into, you get a single pane of results. You make a search. We're going to search in code. We're going to search in issues. Right now it's kind of tabbed search, and I just don't feel that's the best. So I don't. I guess you would kind of need hybrid search, because I think I actually haven't read the paper on code search. I don't touch that within GitHub, but I believe it's represented as vectors. And if that is the case, then yeah, you would kind of need this hybrid search to figure out like, hey, are you searching for an issue? Are you searching for code? Does that kind of answer your question, or did I miss the point there?
No. I mean, to your point that you much earlier, like, hey, it turns out across GitHub, certainly across ours, actually multiple different search engines for multiple different use cases actually makes a ton of sense. It's not one search infrastructure with a lot of bells and whistles, it's actually multiple.
Yeah.
We have this kind of crazy case that for us turns out to be the very common case at the very core of our like IP of our product, that somebody describes a problem and our search engine, our engineering assistants, are expected to respond with all of these different automation scripts that are a solution to that problem, but there's no lexical overlap in between the description of the problem and the title or the documentation of any of the scripts used to solve it.
I see. So
our example is like using like the Kubernetes online boutique terminology. The cart service is down, or the cart service is and the right script one is the online boutique namespace pods. Check if the online boutique namespace pods are healthy. There's like not only no lexical overlap, but the conceptual overlap of the cart service is a knowledge graph question relative to the concept of the online boutique namespace. So we actually do a hybrid of knowledge graph traversal, which turns out for us to actually be the high order bit, along with BM25 and a vector search.
I was gonna say this feels very much like there's a word for this, like this not asynchronous. There's a way that you can represent embeddings where it's like, hey, this is my input and this is my output embedding, and that allows you to traverse both and say, hey, even though I know you're talking about the cart service, I recognize that is a component of, like you said, it's combining that knowledge graph into also the text search portion, because you're going to have to turn that text search into a knowledge graph query to say, all right, well, where does this belong within the grand scheme of things? And then you can kind of do like a, what is that called, radius search, like where you start searching larger and larger radiuses to see if you can find some solution. But no, that's a really interesting problem. That's interesting.
I'm inspired by what I never worked close enough to it to know, so I'm just guessing what the database underneath looks like for Google Maps, right? Where a vector representing a restaurant encodes not only the title of the restaurant, any web pages about the restaurant, but it also includes the location of the restaurant, the cuisine of the restaurant, the fact that it's a category of a restaurant, as well as latitude and longitude, so that one search you can kill a lot of birds with one stone.
Yeah, exactly. Actually, it's interesting though, because you kind of mentioned vectors there, but at least within OpenSearch, like when you do geography-based search, it's more often than not, just a vector of location, and then it will narrow down the BM25. What is that called? BM25 portions, indexes, are built into segments that are then, searched across with BM25. So like you'll grab, basically, you might say, hey, in it that matches these coordinates within a radius, it'll grab all the segments of BM25 that kind of match that, and then it'll do BM25 search across those.
Yeah.
I don't know how Google Maps is search, but yeah, it is very interesting trying to, build in these coordinate graphs along with, doing traditional BM25 search.
For us, it turned out to be critically important because not all of the time, but most of the time, the higher order bit when somebody gives us a query of like the cart service is down, is try to figure out where in the infrastructure the cart service actually lives. What are all of the things that we can do for that general area of the infrastructure? Make sure we're not like accidentally troubleshooting prod when the question was about dev.
Yeah.
And then kind of re-rank within that space to say, all right, now within that space, all the other things matter, but it doesn't matter if we're troubleshooting the pods that are down someplace totally different.
Yeah. Well, and that's also where that LLM like understanding is really important as well. Like, because you can, generate a list of things that need to be checked. Like, all right, or where's our namespace? Like, are we talking about dev or prod? Where then go search and find things that kind of match this, within our knowledge graph, and that like. That's where I kind of like the agent model a lot, although it can be potentially very expensive. But
I want to say, Abdel actually had one more question that I wanted to flash up on the screen, and then I know that we're over time and should wrap up. But let's try to squeeze in this one more question.
Absolutely, yeah. So how do we approach selecting the embedding model for our use case, namely observability and SIEM use cases that are not benchmarks for the famous models out there? This is actually really tricky, and I've got a very hot topic on this, and that is that I don't think most people should be embedding their observability data. And I say most people because this is where like so many of the models that are out there that are trained, that are readily available, are semantic models. They're meant to understand sentences, and you'd really want one that is trained specifically on observability, like security use cases. And unfortunately, not a lot of people I feel like are open sourcing those right now because it's like their company's internal, product. Their product is producing those embeddings and finding that for you, which does raise the question: why is it that we have so many like semantic models out there? But yeah, honestly, I don't know that I have a good use case for you or a good answer for you, other than also asking yourself like, what do you anticipate you'll get out of this? Like, do you believe that you're going to get a better results by using embeddings? And why is that? How do you plan on using that? That's where I start with most people, because I think for most observability use cases, embeddings are they're very heavy and they're very expensive.
Yeah. I mean, I can answer also and I couldn't tell actually, maybe those questions for us too on the RunWhen side. On the embedding model, I mean, I kind of touched on it a little bit. We use a really simple model. We actually just use Distilbert for the text part of. We do a lot of query processing, and then we use something literally as simple as Distilbert. We got the exact same results from Distilbert and OpenAI because that actually only represents a small part of the overall vector. All of the words in a query represent a small part of the vector. Where that query represents in the infrastructure represents a much larger part of the query. Who the user is and their history represents this material part of the query. I think it's kind of the point that you made earlier, trying to get all of these other hints about what the user's intent is. We spend a lot of time trying to get whatever signal we can about user intent, and we bake it into this really, really big vector. And what the user actually typed is like some of the intent.
Yeah. And that's what Google is famous for, is that they're just knowledge and understanding of user intent is, I think, so much more vast than people give them credit for. And that's why they're able to say, hey, David's a software engineer. When he looks up, Ruby, he's probably not looking for gemstones.
Yep. A funny story on personalized search and my old roommate, but we'll talk about that some other time. David, this was so wonderful to have you on. I love these kinds of conversations. I mean, this is just like the highlight of the week type of thing. Before we totally close out though, there's one question that I always like to ask people who come on.
Yes.
what career advice would you give to your former self?
Mm, mm. Uh, it's probably two things. It's two things. It's one, ask 10 times more questions than you think you ought to. I think so much of my career was spent, like just trying to figure everything out on my own and just like expecting that I should know these things when the truth is nobody just knows it. Everybody goes and they have to learn it somehow, and asking questions can be one of the quickest ways to get there. And then the second part is just ship it. There have been so many times that I've just like puzzled over the right way to do things and what's the most secure architecture and what is the like most robust scales, etc. More often than not, you just need to ship it in order to start getting that feedback and to start evaluating, did I do it right? Was there something I could have done better? There was a handful of cases where I just shipped it. I ended up rewriting the service 3 times. However, by the third time that I've written it, it was 10 times better than if I had spent all this time working on just doing it right from the start. I mean, I just never would have gotten it right.
Sage advice, man.
That's it. That's what I'm here for.
Thank you so much for coming. This was a real treat. This was a real highlight. I think everybody, everybody who tunes into these things just.
I'm glad to be here. Yeah.
Thanks, Tom. For everybody else, we will have we'll be on again in about, I believe that we have one more coming up. But Maggie will keep me honest before KubeCon London. We look forward to talking again in a couple of weeks. We have a fantastic lineup coming up afterwards. We'll see you very shortly. Thanks all for tuning in.
Thanks.